Welcome back, scholars. A quick reminder before we get to our key point is that I do look at your work on each slide, so please don't skip over slides. Take it step by step and type in an answer or draw or whatever it's asking you to do, please do it. That way I can see you worked through the lesson step by step, and don't just skip ahead to the exit ticket or anything like that. Okay, I really want to see your work. All right. Let's go ahead and get started. Your do now was a very good example of translating and using a model. Today, I'm going to show you a strategy on how the model can actually help you translate. So our key point today is about creating a model. So creating a bar model can help translate mathematical descriptions to equations. And I want to speak a little bit on this. It's important that we understand this can help. Not everyone's mind works the same way. We are different types of learners. So if this strategy is kind of backwards to you, you think to an equation before you draw a model, that's okay, that's fine. This is just a strategy to help you if you think more visually, if you can draw and then figure out how to do the math, okay? So you can take it step by step. I'm going to show two strategies and you do what is best for you to solve, okay? Example number 1. Write an equation that represents 5 less than, I'm going to annotate less than means that I'm going to subtract. What am I going to subtract? 5. Remember, this is opposite. It's minus 5 at the end. So I'm going to subtract 5, then some number, that's my variable right there. I'm going to use n, is 20. Now, we're actually not very familiar with this yet. We've never translated anything like this yet. So I'm going to tell you what the is stands for. Usually, the is going to be an equal sign. So 5 less than a number equals or is 20. Just like when you answer any question, what is the answer? It is 5 or it is 223. Is like an equal sign. So you can translate it into equals. So let's see. If I take away 5 from something, I'm going to get 20. How would I draw this in a bar model? So I'm going to have some type of total. And if I take away 5 from my total, that some number, I will get 20. So if I think about that bar model, I have some number. I'm going to have to take away 5. Pretend I'm crossing this out. And when I take that away, I end up with 20. Now I know this model. Now that I've drawn it, I understand it. Now I can write my equation. So obviously my total comes first because I'm going to be subtracting. Take away that 5 and I end up with 20. Okay, now if you could translate right away, you read this and you're like, oh, I know how to write the equation. Great, good for you. But this model actually helps us think about what is really happening. I'm taking away 5 from something and I'm left with 20. So now let's solve. All right, some number, I take away 5, I end up with 20. Well, I have 2 parts and I'm missing my total. If I add those 2 up, I should get my total. 20 plus 5 is 25. Correct? Yep, pretty easy. Still gonna check my work. Still gonna double check, use some mental math. 25 minus 5, is that equal to 20? Yes, it is. Excellent. So my n is going to be equal to 25. Okay? So just use a model, and then I check and solve. All right, let's try one more. Write an equation that represents the quotient. Ooh, what does the quotient mean? Division. The quotient of, oh, look at that. If you remember, I always want to connect my of and my and. of something and something. So the quotient of 25 and a number is, what does that is stand for? Equals. So equals 10. So let's try and figure out where would my total be and what would be my size of group and number of group, because that's the type of model I need if I have division. The quotient of 25 and a number. So 25 divided by a number, I don't know how many groups I have, but I will end up with 10. When I split it into n number, I don't know how many groups, but I split it into groups, what I will have left over is 10 in each group. So let's check, let's figure that out with an equation now. Well, I have my total up here. I'm going to divide it by my number of groups, and I'm going to be left over with 10. Did that translate well? Yep, 25 and a number, 25 divided by n is equals 10. All right, now all we have to do is solve. So 25 divided by something equals 10. Well, how am I going to figure out how many groups I have? Well, I have my total and I have my size of group. If I'm just missing my number of group, I'm still going to divide. So 25 divided by 10. Now, if you think back to 5th grade, when we divide by a power of 10, what can we do? Boop, just shift our digits. So if I shift it over once, I get my 2 here, then I would have a decimal, and I would end up with 2.5. Now let's check my work, see if I'm actually correct. 25 divided by 2.5. Oh, I don't want that decimal. What can I do? Shift it over. This would become 250, and this would just become 25. All right, how many times is 25 going to 25? Once. Excellent. Bring down my 0. How many times is 25 going to 0? 0 times, and I'm left with no remainders. So my answer is 10. Is that what I wanted? Yes. All right, now I can confidently say the answer, that missing number, is 2.5 or 2.5. All right, for the rest of this lesson, I want you to use the strategy that works for you. Drawing the model, writing the equation first, whatever works for you. The goal is, can you translate the descriptions into equations? Good luck, and I can't wait to see all of your work on today's lesson.